Imagine a world where your body becomes the ultimate remote control. Every subtle clench of your fist, every delicate sweep of your hand, instantly replicated by a robot far away, offering an unprecedented level of precision and intuitive control. Today, this might sound like a futuristic fantasy, but tomorrow it could be a reality. H2L, a Japanese startup, is pushing the boundaries of human-robot interaction with their revolutionary Capsule interface, a technology that could transform how we control robotic systems. At the heart of the Capsule interface lies a sophisticated system that captures and interprets minute biosignals from the human body. This includes electrical signals from muscles, changes in blood flow, and other physiological responses. By decoding these signals, the interface can translate them into commands that drive a robotic arm with remarkable precision. What sets H2L's approach apart is the sophistication of their signal interpretation. They've developed proprietary algorithms and sensors that can pick up the subtlest muscle movements, even when they don't involve visible contractions. This is achieved through a combination of electromyography and other proprietary sensors. EMG, a well-established technology in medical settings, measures the electrical activity of muscles, providing insights into their state of activation. By placing electrodes on the skin surface, the interface can gauge muscle tension and movement intentions, even before they manifest physically. This is akin to sensing the intent behind a slight frown or a raised eyebrow, translating it into a command understood by a robotic arm. But the magic doesn't stop there. H2L's interface goes beyond simply reading muscle activity. It also takes into account changes in blood flow, heart rate, and other physiological signals. These additional data points provide a richer understanding of the user's intent, allowing for even more precise control. For example, if a user tenses their muscles while also displaying signs of relaxation elsewhere, the interface can infer a change in focus or a shift in attention. This contextual understanding allows for a more nuanced interpretation of the user's desires, something akin to anticipating the next move in a dance, ensuring the robotic arm responds not just to the command, but also to its context. The beauty of this technology is its potential to blur the lines between human intention and robotic action. It eliminates the need for complex controllers or cumbersome interfaces. The user's body becomes the interface, their thoughts translated directly into robotic movement. This direct neural-to-robot interface minimizes latency, reduces the need for complex controllers, and enhances the naturalness of control. It enables a more intimate relationship between human and machine, where the robot becomes an extension of the user's will. The implications of this technology are vast and transformative. In tele-surgery, it could allow surgeons to operate at a distance, controlling robotic arms with the precision of their own hands. For disaster response, it could enable robots to enter perilous zones, mirroring the movements of human operators who remain at a safe distance. In manufacturing, it could guide robots through complex tasks with the finesse and accuracy of a human worker. Moreover, it could revolutionize fields like prosthetics, allowing amputees to control artificial limbs with their thoughts, blurring the line between human and machine. The technology also holds promise for VR and AR, making interactions more immersive and intuitive. Imagine manipulating virtual objects with the precision of your own hands, your digital avatar's movements mirroring your own. While the technology is still under development, H2L has already made significant strides. They've successfully demonstrated the interface in various settings, showcasing its potential for tele-surgery, disaster response, and manufacturing. The company has also partnered with universities and research institutions to further refine the technology and explore its applications. Despite the immense promise, challenges remain. Miniaturizing the interface, ensuring robust signal interpretation across diverse body types, and enhancing long-term user comfort are among the hurdles that need to be addressed. Additionally, ethical considerations, particularly in sensitive areas like surgery, will require thoughtful regulation and public discourse. In conclusion, H2L's capsule interface is more than just a technological innovation. It's a glimpse into a future where humans and machines merge to achieve new levels of precision, control, and capability. As the technology evolves, it promises to blur the boundaries between our physical limitations and our boundless potential, allowing us to reach, touch, and create in ways we've never imagined.